P9, please go ahead.
Good morning, everyone. Today, we are the first group to present our database project. And basically, the topic of our group is a database designed for an online education platform. And here's our story. So first of all, I will introduce something essential of our topic. Things like why we choose this topic, how we make our decision, and what we can achieve. Then I will show you how we design our database. I will introduce all the entities we have along with the diagram. After that, one of my teammates will explain how we implement our database, and another one will analyze the result in detail. Finally, we will hold a Q&A session, and you can ask whatever you want to know about our presentation. Okay, so let's get started. So why we did this? As we all know, internet is a massive power in new technology which spreads really fast around the world. People can do a lot of stuff. They can communicate, find answers, get information, and much more. Along with this, online education platforms become extremely popular. Those are some platforms we are familiar with. And as for our missions, so our database maintains the relevant data to support and improve the online education services of the platform. From the supplier perspective, it helps the company earn more money. Besides, it will also provide better user experience to both students and instructors. Okay, so let's see the design of our database. So this is the diagram, and you can see we have 12 entities. The account holds the record of all types of users. We have administrators, instructors, and learners. So our administrator is responsible for supporting all the contents through this support. And a content can be everything, such as the reading textbooks and the lab content or the video records. And moving on to the instructors. So one instructor can create multiple courses, and they can give feedbacks to students through this feedback entity to optimize the students' performance. And the payment to the instructor is recorded into this paying row. And we have our learners. So our learners can browse and register all of the courses through this enrollment. And also they can get their grades of the quiz through this quiz. And a certificate can be given to a student according to their performance in the quiz. That's the design of our database.
Hello, everyone. Let me introduce the detail of our database. I will show you our SQL. First, we use the different types of data and the different ranges and the primary key and the foreign key to create the columns. For example, in the learners table, we use the 20 size of the varchar to create the first name and last name, and we use the 50 size of the varchar to create the email address. And we also use the get data to automatically create the age. Second, I will show you some function of our database. For example, the first function is created by course and the enrollment table. We insert the data into the start time of the course table, and the start time should be later than the enrollment date of the enrollment table. If the start time is earlier than the enrollment date, the constructor will check the current to be 0. And in the second function, it's the same. The rule is the date difference between today and the last pay day. It should be less than 30. It means every course has 30 days for students to study. If it's out of date, the constructor should be active and the student should pay it again to reactivate the limited of the course. In the third function, the condition is enrollment date should be later than the last pay day. And in the fourth function, the ID of the quiz 2 should be bigger than the quiz 1, and the pass day of the quiz 2 should be later than the quiz 1. For the data encrypt, we have a table called the paying role. So we have the personal card number information. This data is very critical. We need to encrypt it. So we use the mask key and the certificate and the symmetric key to encrypt it. And we also use the AES-128 to encrypt the data. Then alter the paying role table. To ensure the accuracy of the encryption, we open the symmetric key to decrypt the card number. The last part of the SQL is views. In the first view is a report of the payment. It stores extract ID and the student information and the total day of the payment. The second view is a report of certification. This view generates a list of the grades and the certificate, the day of the certification, based on the distinct of certification ID. We can use it to analyze the learners of a study. Okay, let's move into the next part.
Okay, so after the could you pass the next slide? Yes. After the implementation of the SQL codes, we carried out some analysis and visualization through Power BI. As you can see in the first graph, the learners are split into professional and student. We can get the average age by type. We also plot enrollment number by year, so we can see the marketing trends clearly. We can notice the huge decline after 2016. Maybe the platform should readjust the marketing strategies or check the quality of courses and services. And the next page shows the learners' location. They are all over the US. The two graphs show the proportion of learners by geographic position. Most learners are located in CAMA and New York. And the next graph we have is the average grade of courses. It is corresponding to the table below and somehow shows the difficulty of each course. The right graph is the certificate achievement rate by course categories. The business category has the highest completion ratio, while the health category does not have anyone finish the courses yet. Maybe we should check the courses difficulty later. And finally, the next page, yes. According to one of our view tables, we made the bar graph to compare each instructor's revenue. As you can see, there are clear gaps of revenue among instructors. It also can reflect the popularity of the instructor. So that's all what we have done. Thank you for your attention.
Excellent presentation. Any question or comment for Team 9, please? Okay, then we will move on. Thank you very much for the good work, Xiaoying, Mingji, and Jin Xian. Excellent presentation. Thank you. So Team 1, is Team 1 ready?
Yes, we are.
Yes, we are ready.
Okay, can you guys see my screen?
Yes.
Okay, so good morning, everyone. I am Hardik Soni. I'll be talking about the sales order management system for an agrochemical company. So let me talk about the purpose of this particular system that we have. The purpose is to manage and store data of a typical sales order process within an agrochemical company, where the sales agent book orders for customer by specifying the suppliers, the shipment agency, and the price list in which the orders were sold. The business problem that we are trying to address with this particular system is to evaluate the sales performance by employees, regions, and products, comparing their actual performance versus the target which was set. In addition to this, we can also link the price list to the products within the orders, allowing the entire sales process to be flexible and link the customers and employees together with the orders to give an insight into the performance. So I'll further pass it on to Matt to give a highlight on the design in the ERD.
Good morning, this is Matthew Pearson. Here is the ERD for our implementation. The regions, employees, and products entities all have target entities related to them containing sales goals. These are integral to both our views and reports and will be highlighted later by Hardik and Satish. The products and order entities are associated with a price list that itself has price list items. A price list is also related to the employee that created it. In addition, orders are related to a currency with an exchange rate, as well as the shipping company delivering the order. This quickly summarizes the most important and notable entities of our database. As part of our implementation, the following features were added to make the database more robust and complete. For telephone numbers, a check constraint was added that uses a regular expression to make sure phone numbers are entered in the desired format. Also, the employee entity keeps the social security number of the employees and also encrypts it for security purposes. Finally, the order item entity has a computed column of total price. This makes data entry faster and simpler.
Good morning, everyone. I'm Satish Kumar Shivalingam. I'm going to present about the key business metrics with views. So you can see on the right hand side there is code for the view, and on the left hand side you can see picturization of like what are the tables that are used to create this view. You can see that the order table, employees table, regions table, and the employees target table are joined to create a view called as employee actual versus target sales. You can see that the target sales of different employees are different for different employees, and also the actual sales achieved also was mentioned, and you can also see that the actual sales that was achieved is much lesser than the target sales. And in the next slide we'll see another important key business metrics called as monthly customer sales. Again, the codes are written on the right hand side, and on the left hand side you can see the picturization of the tables that is used. You can see that the order table, employees table, and the regions and the customer table are joined together to create this view of monthly customer sales. You can see like what are the different sales for different month and year, and you can see order month 2 and the year, and also the region. So it gives you the total customer sales, and I'm handing over the reports to the Hardik.
Yeah, so based on the views that we created with regards to employees actual versus target and the monthly customer sales, we could use those views, create an extracts in Tableau, and create dashboards out of it. So what you look here on the left is the employee-wise sales for a month. So the blue bars actually indicate the actual sales, and the black borders here indicate the target which was set for the employees. What you see here on the top is the month-wise performance of the entire organization. So how is that entire organization doing for that month with respect to sales, with respect to the financial numbers. What you see here in the between is the customer-wise performance across month. So you could basically have a trend across how the customer is performing with regards to the sales on a month-by-month basis. And what you see on the right is the region-wise performance. So you could get a high level just on how each of the regions are doing, and the amount of sales that each of the region is doing. So you could also filter this data by either by month or by a manager or by an employee. So this is what, in an overall nutshell, the sales order management system was with regards to the design, implementation, the views that we created, and the reports that we could generate out of the views. So do you guys have any questions?
Great presentation. Team 9, are you ready to ask a question?
Hi, thank you for sharing your database. And I'm really curious about the last page about the right side of the picture, because I just saw the data is just come from the Midwest and the Northeastern. So I'm very curious about for your whole data. So that means you just choose these two average, or you choose the whole country's data? Thank you.
Yeah, so this was the data that was fed into the system, and we actually booked a couple of transaction orders within the system. So depending on the number of users that we entered in the data for in the system, these were the orders that were booked from. These were the regions that the orders were booked from for a particular employee and the customer. So once you have the data fed into the system for the remaining regions as well, like Southeast, Southwest, and West, you could also get in this data on a real-time basis on the dashboards. So I hope this solves it out.
Okay, thank you.
Great. Thank you for asking the question, Team 9. Any other question or comment for Team 1, please? Great. Thank you very much for the good work and presentation, Matt, Hardik, and Satish.
Thank you.
Great work.
Thank you. Thank you very much. Yeah.
Okay, great. Is Team 2 ready?
Yes, we are. Give us 2 minutes. Can you hear me?
Yes.
Okay.
You are on, Team 2.
Just sharing. Give us 1 minute. Okay. Good morning, everyone. We are Group 2. My name is Akshay. We have Abhijit, Anmol, and Hari as well. And our project is designing a stockbroker toolset. Next slide, please. So giving a quick overview of the project, as we all are aware, with the huge growth of data and assets, individuals and investment managers are not well positioned with the right knowledge to make an optimized trading strategy. With that in mind, the purpose for us was to evaluate the raw set of data, which would include the different parameters for the Fortune 500 companies and help with the decision making to achieve better investment outcomes. The objectives of our project were as follows: to be able to determine the volatility of the stocks of the different companies based on these parameters, an easy-to-use module, movement of the stocks within the past 100 days, which could represent how the strategy changes, and finally, a visual representation via a dashboard that helps us to view and make a comparison of the stocks. Next slide, please. For a design document, as you can see, we have provided a snapshot. In total, we had about 12 tables and with different entities. This illustrates the description of each entity, how each one is related to other entities in the ERD, and what changes we made going from our initial.
Hi, my name is Anmol Roila, and I'll be explaining the ERD. So here we have industry and company. We have 12 entities total. So the company is related to the industry. There are different industries. For example, if there is tech industry like Google, and there's a finance industry as BofA. So there's stock data that consists that's connected to the company with a ticker symbol. Ticker symbol is an abbreviation that we have used that is used to uniquely identify the companies. And the stock data consists of all the sales data that are related to the stocks. And to go to the date data, it connects the stock data on a particular date, the explicit data of the stocks that were on that particular date. And we have connected it to news that gives us a connection of what were the headlines related to that company, related to the stocks on that particular date. Then we go ahead with the company, more data about company in the company data table about the CEO and the vice president. And then we have employees and customer here who have been connected by an associative relationship. So the employees are basically the agents who are trading between the customer and the company. And employees and customer both have transactions that consist of the stocks that they have bought or sold. And all the details that have been linked, they have been linked to the accounts. That also calculates the revenue that will be explained later. And the customer and the employees have a many-to-many relationship. where they trade and exchange transactions. Thank you.
Hi, my name is Hari, and I'm going to be explaining about the implementation of the database using DDL or DML commands. So as you can see, we on the left-hand side, we have the DDL commands for creating different entities, which are the industries, which have a primary key for the industry ID and a varchar type for the name. And moving on, we have the company, which has the company ID as the primary key and industry ID, which is referenced from the foreign key. We also created a unique index over here because a ticker symbol is not present in the primary key. And we have the stock data with the date time as the primary key and creating a unique index again on the date. Moving forward, we have different functions and triggers and check constraints that we used. So to start off, we are creating a stored procedure for setting the revenue of the transaction table. So over here, what we do is we check whether the stock is sold or stock is bought. So if the stock is sold is not, if the stock sold is not null, then we give the revenue as stock quantity multiplied by the stock sold at. Same way for the stock bought at, we give the negative of the stock bought at into the stock quantity. We are also creating a trigger for the stored procedure that is, it depends upon the account ID that is passed on. So as you can see here, we are setting the revenue, we are returning the revenue value depending upon the customer ID. Moving on, we have the table check constraint for the department check. That is, we are only assigning the finance department. Our finance department has a department ID 1. So if we are having the finance department in the transaction table, then we are moving on with the transaction, or we are not. If the department ID is not under finance department, then we are not moving on. Next slide. Yeah. Okay, then we had created 2 views also at the same. Okay, yeah. So we have different insert statements. Here you can see we have inserted different values into the departments. As you can see, one, as I mentioned, 1 is for finance, 2 is for healthcare, etc. And we are also populating the address. Next slide. Here we created 2 views. These views are very helpful for reporting purposes. So in the first view, we can see account ID, account number, and bank name and revenue. So these are taken from different, the 2 tables, which are account and the transaction table. And for the second view, you can see the stock name and the count of each stock. So this basically tells us how many times the stock has been bought or sold in the transaction table. And we have used these DDL commands for the reporting purposes.
Hi, this is Abhijit, and I'll be taking you through our final generated report. So our first report basically tells us that we have 3 particular agents who work in the finance department, and then you have them faceted by each customer that they handle. So this basically tells us the first agent handles 3 customers, the second agent handles 4, and the 7th one handles 1. And the reason you see a negative revenue is not necessarily saying that it's generated a loss. However, it's telling us that that particular customer has bought a stock and not sold it. So we're treating bought stocks as negative and sold stocks as positive, just to get a better understanding of how revenue is flowing through the system. Now, coming through our second report, what we have here is stock information through for different companies, and we have the open, high, low, close values for each stock. How we got the data for the same is through running a Python script and basically calling an API for stock information through an API called Yahoo Finance. And once we got all those information, all we had to do was build a database through a union of all the company information. and then generate the open, high, low, close values. And this will help every agent to be able to compare the various stock data and then suggest possible options for the customer to invest in. Our third report is basically the various prices and the amounts at which each customer bought various stocks at. And yeah, this is a very basic report to just understand what customer is generating what kind of revenue to the company. And our final data set is very similar, except it's telling us the quantity of transactions that each customer is doing, while the previous one was talking about the revenue. This is probably this is mostly talking about how much of stocks they are investing in. And yeah, that's about it. Please ask us if you have any questions.
Hello, this is Matthew Pearson from Team 1. In the ERD, there was news. There was a news entity. I was just curious in how this figures into the database. How is this used?
Right, interesting question. So the reason we decided to add a news column was not really in terms of database implementation. It doesn't really help the agent too much. What we were thinking of implementing it was mostly for the data science team that could probably do some sort of modeling and do some sort of sentiment analysis to be able to determine whether any of the news information coming out on a particular day impacts how the stock is functioning or how the movement of stock is taking place over the next few days. So that's some interesting concept that we decided to implement to our database to be able to get a better understanding of the movement of stocks.
All right, thank you.
Thank you.
Oh, sorry, I was muted. So just a quick comment. When you are not talking, please mute yourself. We had a little bit of echoing. And thank you very much for the good work and the presentation. Hardik, Anmol, Abhijit, and Akshat. Team 3, you are on.
Okay, can anyone here see our screens?
Yeah, we can see your screen.
Okay, so we are Team 3, and our database topic is food delivery. And first of all, let me give a brief introduction to our database topic and our point of view. So basically, the business model and key components should be totally as same as those common apps on the market. For example, like DoorDash and Uber Eats. And we based on the need from different point of view, like customers, food deliverers, restaurants, and other aspects that we develop this database to in hope that it can be put into use into like the real industrial environment. So how could this database could be used? We try to thinking from different angles. First of all, from the point of view of customer, the customer just want to order foods from a restaurant, and hopefully their food will be delivered to their address. And also, a food deliverer should be know that where to pick up the food and what food should be picked up and what address should be reached. And also, the restaurant should be able to update a menu of foods and also count what they earn, and also try to manage the order they get. Finally, as the food delivery service provider, the provider should be able to manage, to estimate, to get to know what amount of people is using this app, and also what amount of order is running through this system. So based on those needs, we develop our database system.
Hello, I'm Qinhu. This is our entity relationship diagram of food delivery database. And we normalized our design to the third normal form. We totally made 15 entities and related them among one-to-one, one-to-many, and many-to-many relationships. I will use two examples to show the details. First of all, the relationship between restaurant and owners is one-to-many because one restaurant could have more than one orders. Secondly, placed orders and dishes, because one order could have several dishes and one dish could also be included in many orders. So this is a many-to-many relationship. In order to remove this, we built an order dish table. This is a quite important normalization in our design.
Can anybody see my dbeaver?
Yes, we can see. No, not yet.
No.
Okay, now we
Okay.
can see it.
Yeah. Firstly, we create some tables. I think every group do these things. Let me introduce some features about our database implementation. In this part, we create a function called get order total. We use some table, our order table, dish table, and order dish table to calculate the total price of one order. And we add a computed column in called total price into our order table. In this part, we create some master key, certificate, and use a trigger to encrypt the password after the user is inserted into the table. In this part, we use a procedure and a while loop to generate some random data into our database. This is also to generate some data. And in this part, we create a procedure called pay. It will create the payment record automatically and pay the money from the customer to the restaurant owner. We use the transaction to match the consistency of the data. And this part is insert the data and this is about view. Let me friends to introduce this part.
Hello everyone. Hello everyone, this is Yutong Yan, and I will show the report part. The first view table is to retrieve the detailed information of orders. So we mainly used inner join statements to connect 7 different tables. Pay attention, we also used 2 template tables to get the information of customer deliver. Let's see the treatment results. We can get a very detailed order list. Well, in the second view is a ranking table. Depending on the total revenue of each restaurant, we use the rank over statement to get the top 10 popular restaurants. And this rank is with ties. And for data visualization, we used the software of Tableau. And the first one, according to the longitude and latitude parameter, we got we could get a map graph, and then the sum of total price could be same as the value to show the map. The second one, we used horizontal bars to show the open and closed status of restaurant. According to the graph, we know that most restaurants are open from 7 to 9 a.m. and closed at 8 to 10 p.m., which will help us to manage the deliverer's working time. Well, in the summary, we presented our project from the perspective of business purpose, ERD graph, implement, and reports. Thank you for your listening, and feel free to ask questions.
Great
Hello?
presentation. Question and comment, please.
Hi, this is Abhijit from Group 2. I was just wondering, because your application is so incredibly dynamic, and obviously the number of customers can increase exponentially over a period of time. How do you deal with the memory management of your whole database? Because the number of restaurants keep increasing, the number of customers keep increasing, and basically everything's increasing so exponentially.
Hello?
Yes.
Yeah.
Go
So,
ahead, please.
so it is really a good question. So, basically this amount of data we experimented so far is just for, it was a small amount of data, but I think we believe as the amount of data increasing, that we can sort of based on the database logic so far, we can implement it on a sort of distributed database system to fit the keep increasing big amount of data that need to be stored. And also the you mentioned that the data should be very dynamic and also big amount, but to be honest, from the real world perspective, those data need to be stored in the system, in a database system should be like, they're they are really varying depending on time, but after they are settled, they are hardly to be visited or used in a very frequent way. So basically, I think we can like migrate them to distributed database system just for storing purpose, and also we should be maintaining a high speed or a very dynamic cluster of database system to maintain the working environment. Thank you.
All right, great. Thank you so much.
Great. Great work. Thank you, Sim, Yutong, Minjian, and Xiangxi.
Thank you. Thank you.
Okay, great. Great work. Thank you. So team four is up. Is team 4 ready? So do we have team 4 in attendance? Okay, is team 5 ready? So for team 4, we have Renuka, Roham, Niha. So let's see. Okay, so team 5 is ready, right? Is team 4 which? Okay, so why don't we let team 5 present now? So team 5, please present. Okay, team 5, you are on. We can see your screen. Go ahead, please.
Okay. Hello, everyone. This is team 5, and our topic is about the project management database for a consult company. So as in a company, there are many projects, so it is very important to allocate each time and employee appropriately. So here, the database is to help the consult company to manage their projects. It is used by administration staff like a director and a project manager only to maintain the data used to generate and support project management. The business problem addressed here is allow the director and project manager to generate and support project management, and provide information to help project managers to allocate like time, employee, and expense for each project appropriately, and also permit the director only to track the process timely. And here is the entity relationship diagram. We have totally 12 entities. Let's start from the top first. As many clients may come from the same client organization, so here we use entity to avoid the duplicate. And each project is proposed by one client and is managed by one manager. So here we use a relationship to indicate that each project only have one manager, and each project can be divided into many work packages. So the employee is directly works on the work package, not the project. So here we use a the two associative entities to indicate the many-to-many relationship. The first is the time cost, and the second is the expense. By tracking the time of each employee working on the work package and the expense they spend on each work package, we can calculate the total reward of each employee. And for each work package, we have many documents, and each document is reading by many employees. So this is the total design of our entity relationship design.
Can you hear me? Can anybody hear me?
Yes, you are.
Hello everyone, this is Lu Qingjing, and next I will briefly talk about our database implementation. First of all, because our ERD clearly shows the columns of each table and the relationships among those tables, I will not talk much about the process of creating tables, adding constraints, or inserting values. But there is a highlight in our value insertion process. We create a trigger that can update the value of approved by manager in document entity according to the manage ID in project entity after we insert or update data into document. And the right part is our code. And let's move to the views of our database. The first view demonstrates all projects, clients for each project, and work packages that each project is divided into. We also create a function to get each client's full name for this view. And the second view demonstrates all projects, clients for each project, and work packages that each the second view demonstrates a work package ID and the employee ID. In view number 1 and number 2, we both use a multi-value column for reporting. The third view demonstrates information of each employee. We also use a function to get the employee full name in this view. We also implemented column data encryption to the social security number of each employee. And here is our SQL statements. And now I will demonstrate the reports that we created. And in report 1, we use a field map to show the client distribution in geographic location around the US. And in the second report, we use a bar graph to show each project's proposed cost and actual cost. We can know that in most of the projects, the actual cost is a little bit higher than the project cost. And this report, we use heat maps to show the participation of each manager and general employee. We can clearly see if a staff is contributed to a project in this report. And that is the end of our presentation. Thank you for your listening. And do you have any questions?
Hello, I'm the member from Group 3, and thank you for your presentation. And could you please show your ERD graph again? I have a question about the ERD graph. Well, we can see there are two kinds of lines in your ERD, and one is the dotted lines, and another one is the solid lines. And could you please explain more about why the lines between these, the work package table, time cost table, and employee table, the lines between these three tables are solid, different from others?
Can you hear me?
Yeah.
Because you can see here in the time cost, the primary key is composed by the work package ID and the employee ID.
Mm-hmm.
So this is the identical relationship.
Yeah.
So here in the MySQL Workbench, this is the solid line.
Mm-hmm. Mm-hmm. Yes, it's very clear. Thank you for your answer.
Thank you.
Excellent work and the presentation, Lucy and Shane. By the way, this is a two-member team. Okay, great work. Thank you.
Okay, how to close?
So Team 6 is up.
Excuse me, can you hear me, Professor?
Yes, you are on.
Okay. Sorry. Good morning, everyone. This is Group 6. I'm Wei Xu. Our project is Premier League Club Management Database. Today, we will present our project in the following 4 parts. I'll talk about business background and database implementation. And then Yanhong will talk about descriptive analysis using Power BI. Finally, Zixing will talk about modeling analysis. About our business background. This database is mainly used for football clubs management level, especially marketing team. Our business purpose is to track and analyze clubs' different types of income expenditures per season, to track and analyze other clubs' performance, financial status, and strategy. Finally, we can export different effective and suitable financial strategies for each club. For our database structure, we take club entity as the main part. Design the database by dividing the income and expenses into two parts, and then subdividing each specific item. The next is our ERD design, totaling 12 entities with club income and expenses of these entities. Our data are all from club financial report and the third-party report. Second part is database implementation. The first view is about all types of expenses and the total expenses of clubs in 2017 and 18 season. The second view is about all types of income and the total income of clubs in 2017 and 18 season. The third view combines the first two views to present total income, total expenses, and the pure profit of clubs in season 2017 and 18. We also created a table level constraint to limit each club to a maximum of one main coach. For computed column, we calculated the wage gap between each footballer's salary with average salary of league at current season. Moreover, we also created a trigger to implement the email notification. Whenever someone changes data in the transfer event table, the system will automatically send an email to our 3 team members. Since the class server can't configure the mail server, so we just put the code here. Next is my teammate Yan Hong to present the descriptive analysis.
Hi everyone. I will introduce the visualization data of our group through the Power BI. The first map is the geographic distribution of our main team in England, and the pie chart shows the Premier League competition bonus share. Manchester City Club gets the most bonus in the last 3 seasons. The donut chart shows the distribution of nationality of Premier League players, with the largest number of native players in England. And the column chart shows the sponsorship income of each club for 3 seasons, and Manchester United has the highest sponsorship fee. The tree map shows that the highest paid football star in the league is Paul Pogba, who earns £15 million last season. The static column chart shows that Manchester City won the highest broadcast fee last season, and the other 4 teams are basically equal. The orange histogram shows the team's ticket revenue last season, which indicated the popularity of Manchester United is the highest. The column chart shows the salary distribution of different players in different teams. Another clustered column chart shows the salary status of the main players of different teams. It is obvious that the shirt of Manchester United are more popular. The next 3 line charts are the players with the wage gap in 3 seasons. The highest salary is 10 million higher than the average salary. This stack column chart is club finance overall. Basically, every club is losing money. The next 10 maps are the distribution of each club's income and expenditure in the previous season. The highest source of income for different clubs is the broadcast fee. The operating expenses are the biggest expenditure for each team. By comparing the income and the expenditure of different teams, we find out that the highest transfer cost, for another word, by introducing more well-known stars like Manchester City, will help the team to earn a higher broadcast fee, which is the biggest part of club total income. And secondly, the more money invested in coach and players, the better the club's performance in the Premier League and the highest competition bonus. Next, welcome Zijin to introduce the modeling analysis.
Hi, to further unleash the power of the database we have created, we implemented a machine learning algorithm to classify the salary range. And this will help the clubs to decide on the salary range whenever it want to recruit a new football player. It is natural to think that the personal information of a footballer, like age, number of appearances, positions, and nationalities, there is a relationship between those informations and the corresponding salary range of this player. So following that logic, we used the random forest algorithm based on the historic data in the database we have created to generate analysis. We found that the age and the number of appearances of a footballer in a certain season are very influential on the salary decisions. And this slide shows the application of this model in real use. Just imagine that when a club is going to recruit a new footballer and likely to have some reference for the salary you want to provide with, they can just enter the information of this footballer, that like age and position and expected number of appearances in a single season and nationality, and the model will return the salary range for the club to reference when deciding on the salary it will provide with the footballer. That's all. Do you have any questions?
Question and comment, please. From Team 5.
Yeah. Can you hear me?
Yes, you are on.
Yeah, this is Lu Qingjing from Team 5. And we have a question about the part 2 in your presentation. Can you move your PowerPoint to that part?
You mean the descriptive analysis?
No, the part before this. Yeah, please stop here. And the next page. And the next. And please move to the next page. Yeah. Yeah, we saw this error executing query. Can you please explain it to me, to us? Thank you.
You mean this one?
Yeah.
This happens if you want to insert more than one main coach to your data, to your entity. So this is just a warning.
This is a constraint from the system. We just to limit one club, the most have the one main coach. If you want to add more than one coach, so the system give a notification like this. Okay. Can we answer your question?
Okay. Thanks for your explanation.
Thank you.
Wow. Excellent work and presentation. Thank you very much, Yanhong, Wei, and Zixing. Great work. Excellent. Team 7. Team 7 is up.
Hi. Can you see our slide?
Yes, you are on.
Hello everyone, we are group 7 and this is Mingjie. The database we designed is bookstore selling records. It's like an online bookstore system. So our database contains the selling situation and customers' information of the bookstore, and it's designed to help staff manage the store efficiently. Like it would let staff know the popularity of the books or find if there's any shortage of books in stock. And here is a general look of our ERD. There are totally 13 entities, and it has two parts, the book parts and the order part. So the book is the products of the store, and it contains information about books, their suppliers, and stock. It shows the amount of books in stock and help staff make arrangement of the book according to demand. And the order entity has a one-to-many relationship with the book entity. So in the order part, it contains information including customers, delivery, feedback, stuff, and payments. Staff can enter, update, or delete orders, track the detailed information of the customer, get feedback from customer about certain order, and track the delivery condition, manage the distribution of employees and orders, and record the earnings of the bookstore.
Hi, this is Neha from Team 7. So next, we design the database for our problem statement. So this is the name of our database, and this is how we have created the tables using the SQL commands. If you could take to the next slide, please. Okay, so we also implemented the function to ensure the modularity and the scalability in the database. So the main focus of this function was to return the delivery track. So that was one part of it. And another thing we implemented was to safeguard our users or our customers regarding from spamming by using the encryption. So that's there in the next slide here. So we have used the algorithm for AES 128, and it is done using the open encryption, so that avoids the need for two different keys. And in the next slide, we have the picture of how it appears. So this way, only the front and the last end could see the email, no one in between. And from the next slide onwards, here's one point that we came through, that if we are encrypting, another point to look after is you should be closing the encryption keys to avoid the leakage part. So that's about encryption and functions.
Hello, this is Gan Yan from Group 7. Could you hear me?
Yes, you are on.
Okay, so there are three views in this project to report the information from the dataset. The view 1 shows the order with total price greater or equal to 100, and next page is view 2, which shows the most valuable customer who have purchased highest total price book. And the next page is view 3, which shows the top 3 stars with best-selling records and their private information. And the next page is our Power BI reports. The first one is the stock quantity for each books. It's a histogram, and the next one is a pie chart about the customer ID and the total purchase made by each customer. Yeah, that's all. Any question?
Hi, can you hear me?
Yeah.
Yes.
This is Wish from Group 6, Great Work Group 7. Can I ask a question about, can you share more information or some suggestion you get from the Power BI? Right. So what's some results or some suggestion you got from your Power BI to use from your database?
Oh, yeah. Right. So the histogram show the stock quantity of each type of book. So we could find that maybe the 301 it has a full stock quantity, but maybe 309 is a little short, so the bookstore could depend on this histogram and make sure that each book have enough stock quantity for sale. Yeah.
Okay, excellent work. Thank you.
Excellent work and the presentation. Thank you, Minjian, Nihal, and Gang. Group 8 is next.
Okay. Good morning, everyone. Can you hear me?
Yes, you are on.
Okay, this is Qiheng from Group 8, and here is our presentation about Fitness Center Management Database Design. Next, please. Next. Okay. There are 4 parts of our presentations, which are backgrounds and objectives, ERD and entities, views, and the Power BI report. Okay, first, let's talk about background and our objectives. Next, please. A fitness center manager needs to deal with a lot of information every day. The purpose of this database is to assist some fitness centers maintain the data used to manage the staff's facility maintenance, register customers, and so on. This database can be used by the manager to finish their job more efficiently. And here are some of our objectives. First, we will allow managers administrate staffing systems, for example, assist class to coaches and something else. And we will provide information to update and maintain facilities regularly. We can assist VIP customers to obtain related privileges. And this database allows fitness center generate financing report. And coaches can arrange fitness courses reasonably. And also, this database can assist managers analyze and improve locker system availabilities, etc. Okay, from now, Kai Hui will continue on presentation.
Hello, everyone. This is Kai. Can everybody hear me? Hi. Can everybody
yes,
hear me?
you are on. Go ahead.
Okay. Yeah, this is Kai. I will simply to introduce the ERD document for everyone. So each customer have 0 or many classes, lockers, and merchandises. But each customer only have one insurance and only one VIP card. And each coach has one and only one salary ID. So the salary ID is the foreigner key from the salary. So and each coach may have 0 or many lockers, and each coach may be assigned to 0 or many classes. Each coach may have 0 or 1 insurance. And each staff has one and only one salary. Each staff may have 0 or many lockers. Each staff may manage one or many facilities, and each staff may have 0 or only one insurance. Each facility has one and only one maintenance man, and each locker may be used by 0 or 1 people. Each class may have 1 or many customers. And for the special cases in this ERD, the staff ID in staff entity is the same as the facility manager ID in facility entity. Okay, next one to Bo.
Hi. Hi, my name is Bo Peng. Now I will introduce our views of the database. The first view is coach view. It can show the coach of each class. For example, in this view, the manager can know the coach 0011 teach the class 0009. The second view is coach class view. It shows all classes of one coach. We use multi-valued column for reporting. So we can see some coaches have 1 or 2 classes and some coaches don't have any classes. The multi-valued column is more readable than the single value column in our view. The third view is customer coach view. Manager can easily view each customer's name and its corresponding coach. We joined 3 tables to create this relationship between customer and the coach.
Hi, this is our Power BI report. First, we have a table shows how many classes each coach has, and we can also see which coach does not have a class so far. We have clustered column chart to show this information. And we have part chart to display the proportional data. The percentage represented by each category is provided next to the corresponding slice of pie. And our second report, we have line chart, area chart, and also a clustered column chart. This is a maintenance plan in 2019 based on our data set. And so we only have the records in January, February, and March so far. We can compare the changes of data over the same period of time. We can also tell the amount of money for each specific type of facility. The information is clearly displayed. Thank you. Any questions, please?
Hi, this is yeah, you could go.
Hi, this is Mianjian from Group 7. So in your ERD, how do you connect the coach entity to customer entity?
Your question is how do we connect entity coach to entity customer, right?
Yeah. Yes.
We have a associative entity class here, and the class ID is our surrogate key. So that's how we do it.
Thank you.
Thank you.
Great work and presentation. Thank you, Cham, Shihan, Bo, and Kai. Great work and presentation. Team 9 is up. Is Team 9 ready? Oh, Team 9 already did that. My apologies. Okay. So Team 10. Tim, you are on.
Can you hear me?
Yes, you are on.
Hi, I'm Yuan Junyao. Hi, our project. Sorry, we have some technical problems. Chrome 在哪 ？Chrome。你给我看那个没有？哦，这根线吗？这个 Word， 你把 Word 那个发给我就可以。
Okay, you are on. Tim.
Oh, hi, sorry for the delay. Hi, our project is a portion of an electronic products shopping application. We gave it a name eBuy. It allows customers to buy and review an electronic product online. After purchasing the product, the customer can write a short review. Other customers can vote one review of a particular product as helpful. Additionally, we have suppliers who can sell products online and a manager who can view and manage products and coupons. Next, the project is to develop and document a data model for representing entities and the relationships in the shopping application. In the meanwhile, we provide DDL for creating the tables and GML for editing entries in the tables, and DQL for making commonly used queries to retrieve information about the status of reviews and votes from the database. The data model for the project is based on the concept of registered accounts, products, reviews written by a customer, votes cast by other customers for a given product, and coupons used in the payment. We have 13 entities in total. For example, account registered account information, including name, password, role, email, and others. Address is all the shipping address. Account address is the shipping address of the account, and product is a record of all the products. Category is a category of products. Review is a review of a particular product bought by a customer. Endorsement is an endorsement of a product review by a customer. And favorite is a record of all products marked as favorite by a customer. And the card is a customer's card. Card item stores detailed information of one kind of product. Each card can have multiple card items. Orders is a record of detailed information of a customer and the order he placed. An order item in the record of detailed information of the product. Each orders can have multiple order items, and the last one, coupon stores coupon code and discount and the validate which can be used in the payment of the order. That's all the database design part. Next, let my teammate Lin introduce the implementation and the data mining report.
Okay, so this is a SQL data definition part. We use create table to create the tables we want, and then we use encryption for the for protect our to encrypt our data, and also we use insert value to insert all the values in the table, and we create functions to calculate the computed columns that we want. For example, for the total cost. And also we create views. For example, in this view, we create the view to have a view on all the user information. And in this view, we have a look on all the endorsement information. And here is the report for our product analysis. We analyze the product in 3 parts. First is the average ratings, and in the diagram we can see that the highest average rating products are iPad Pro, Q2, and Speedlit. And the lowest average rating, which is 0 star, is the MacBook Pro. And we analyze on the reviews and purchases of products, and in the histogram we can see that the highest purchase and review frequency product is the Q2, and the lowest purchase and review frequency is the Moza handheld gimbal. And also the highest feedback rate, which is the rate calculated by review divided into purchase, is the Q2 digital camera. And also for the favorite frequency analyzed, we can see in the pie chart that the highest favorite count product is the Q2, and the lowest favorite count product is MacBook Pros and handheld gimbal. And also we do the analysis for orders, and for the coupon use frequency chart, we can see that actually all the coupon IDs are used, and the distribution, the differences between our coupon ID use frequencies are not large, but actually the highest coupon use frequency, which is 20%, are coupon ID 3 and 9. And we analyze the purchases and reviews by order, and we can see that the highest purchase and reviews orders by brand are Apple and Samsung, and the lowest purchase and reviews is the Ubiquiti network. And we analyze the purchases by suppliers, and we can see that the highest sales volume is a Sanno supplier, and the lowest sales volume is Rob. But actually we can see in the diagram that the difference are not large. And in the map we analyze the city range by order, and we can see that the most consumer intensive state is California. And also the map shows that our consumers are mainly concentrated near East Coast New York and West Coast California and Seattle. Yeah, that's all for our presentation. Is there any questions?
Okay, this is group 8. Can you go back to your ERDs? We have a question there. Thank you. Okay, I'm a little confused here. I don't know the relationship between your entity account address and between your entity account address and entity amount. And also, can I understand this way? Your entity reveal. Your entity reveal is associative entity between product and account. So your reveal ID is your surrogate key.
Hi. The address entity is stored all the information about the address, and the account address entity, the relationship between the address entity and the account address entity is identified, and the relationship between account address entity and the account entity is also identified. So if you do not have the account address entity, the relationship between account and address, that will be many to many. So we use the account address to normalize the entity design. And can you explain more about your second question?
No, I don't need. I'm good. Thank you.
Okay.
Any other question or comment for Team 10? Great, excellent work, Team 10. Thank you very much, Yamji and Lin. Team 19 is up next. Team 19.
Professor, can you hear me?
Yes, you are on.
Good morning all. This is group 19 and our topic for presentation is banking management system. I'm Pooja and I'm going to give you a brief introduction about our topic. Banks have to deal with a number of customers on a daily basis and have to maintain each employee and customer records and also have to track their activities. All this process can't be done on a paper and it is a tiresome process. Also, banks offer many benefiting services which attracts large number of customers. Due to increase in the number of customers, it is essential to upgrade from maintaining these records on paper to maintain these records in a database. This is the business problem that is being addressed. The purpose of creating this database is to construct, record, and maintain the transactions and services of the bank customers and employees. Also, this database can track and update all the data of the bank customers and employees. Now my teammate Swami will explain the ERD diagram.
Yeah, let's come to the entity relationship diagram. Here we are mainly focusing on employees and customers. Here like a employee as you can see, like here we are entering details for employees, and the customer details are entered here, like with many attributes, like with their first name, last name, and address is being most verified here. And like employees will get like loans, like different kinds of loans will be noted in the loan table, and that is connected through a bridge table. As you can see, employee has a loan. So like and employees can also get insurances, different kinds of insurances, and the same goes with the customers also. And here we are dealing with the alert services and reporting services also for both employees and customers. And the account information of the customers is noted in the account info table, and the bank branch information is also noted, like through branch ID and name, address. So like apart from this, like we are providing card services for employees and customers. So different kinds of cards are being provided, and the transactions, whatever happened, like the deposits, withdrawn, so all these things are noted in the transactions table.
Okay, so now we've explained the creation of database and also the insertion of values into the database. So the banking system final is the name of the database here. And the encryption explained here, as you can see on the slide, will be explained by my fellow teammate later in the presentation. Then if we talk about the database creation, so if like Swami explained the ERD, so we have created different tables for every entity in the ERD diagram. And here if you can see the table, we have the table name table employee. So we have chosen the employee ID to be identity, so we don't have to enter the identity number every time. It can just start from 101 and then take forward. And since it is a primary key, it can never be null. And then if you see the data types of various entities are explained here. And you can see the table how it looks in the lower section of the presentation, the slide. Then for this model, we have chosen two views. So one view is the transaction amount has to be greater if the transaction amount is greater than 50,000, and one is if the balance of any customer is less than 50,000. So the transaction amount view is taken because if there is any transaction greater than 50,000, it from a security point of view, like it's a suspicious case, and it can be recorded and look further into. Also, if the balance is 50,000 for any customer, it can affect the credit card approval process. So this is the query, this is the table for our account balance. Then the query run, if you see the views, the checking balance has to be less than 50,000, and the account type should be checking and not savings. So account type can never be savings, checking, it has to be saving account. So in saving account, you need to have balance more than 50,000. Then this is the transaction table. So the transaction for transaction type 560, as you see, it's more than 50,000, which is 92635, which is shown here in the view section. Now my fellow teammate Swami will explain the stored procedures in detail.
So let's come to the stored procedure. Here we have implemented stored procedure for deposit amount and withdraw amount. So let's come to deposit amount. Like as you can see, like if you are depositing any amount, like that should be added to your particular account. So for that we have created a stored procedure, like we are setting the account balance, like the amount which is already present, so plus the account balance whatever is there. So after executing these queries, like as you can see, like there are so many account numbers. Like for that you are depositing some amount, so that is executed in the above query. So as you can see the output of the transactions, like whatever transactions happened. So for example, if we take the account number 2300, so you are depositing 12,000. So that is noted in the transactions table. So next is like before executing the query, like the account balance for 2300 is 55,100. So after the execution of that query, it becomes 67,100. So as you can see, this store procedure is executed for deposited amount. So let's go to withdraw amount. So here you have to deduct whatever amount you are withdrawing from your account balance. That is noted down here. So here let's take an example of 2300 again. So you are withdrawing 1900. So for that, like a transaction is noted here, like in the transactions table. So next is like a store procedure before after execution, like the account balance. So you can see like 67100 for 2300 account. So after you withdraw the amount, it becomes 65200. So that's how the withdraw store procedure is executed here.
So I'll be explaining computed columns, data encryption, and the visualization part. So as we know, computed column is used to create another column in the existing table. So here we want to know how many loans each employee or customer has taken. So these are the computed column for customer table. Like next slide. Next slide. So here we can see like how many loans each customer has taken, like the loan count. Next slide. So we know data encryption. So we create the master key, then the certificate with an expiration date with the subject as well. Then we create the symmetric key. Here we have used AES encryption standards. We can use DES as well. Then we open this asymmetric key and perform encryption. Next. So next one. Next. So in our database, we have encrypted for the email column of the customer table and email column of the employee table. Next. So as we can see here, the customers, like in the customers table, we cannot see the customer email since it's encrypted. Next. Same for the employee table. Next. So when we decrypt, we can see the data in binary format. This is how it's stored.
这什么？这太无聊了！我操，这。
So after we have to convert it to varchar in order to see the actual data in the table in the database. And next one. Now the visualization part, like, so we want to know where all the bank locations are spread across North America, and this gives us an insight. Next one. So we have different kinds of loan in our banking system. So we want to know how much, what's the total amount of loan taken for each loan amount for the customer table, and this gives us an insight of that. Next one. Then this customer versus loan amount table. So we want to know what's the total amount of loan each customer has taken. So this gives us the information. Next one. So we have like reporting services for both customers and employees, like weekly report, deposit reporting, and monthly reporting. And this graph gives us an example. So most, as we can see, we can say most of the customers haven't chosen any kind of reporting services, and very few have chosen monthly account reporting. Next one. Then alert services. So we have alert services provided for both employees and customers. So this is for customers. So there's a small pie chart of like what kind of alert services each customers have like taken. Like it gives us a total count. Next one. Then we have another table to see how many loans each employee has taken. Next one. So thank you, Professor, for providing us this opportunity to present. So guys, please feel free to ask any questions if you have any questions or queries. Thank you.
Okay, so this is Lin from Group 10. And okay. I just have one quick question. So what is your future enhancement for your database? Like, because we know that for banking database, the security is important. Can you like explain for future enhancement or your like data security?
So yeah, so as you can see, we have like encrypted only the email column of the employee and customer table. In the future, we will want to like encrypt most of our data, and like we want to actually replicate the database as well. Like each transaction is important for us. Say a customer made a transaction and something happens in the database and we lose track. So we don't want this to happen. So we want to like replicate another database and save all the data. And we like since having two databases, so the one database we can give it like read only, so no one can hack in through, because it's just read only. And write only is when we want to like put in transactions into the database where only the administration does that. So we want to do like encryption for, as I said, encryption for all the columns, and then like two database, like a database replication. I think
Okay, thank you.
answered your question. Thank you.
Great question, Lin. Thank you. And great work and presentation. Thank you, Haru, Sri, Swami, and Sujie.
Thank you, Professor.
Team 11 is up next.
Professor, can you hear me?
Yeah, you are on. Go ahead, please.
Okay. Hello, everyone. We are Team 11. I'm Bo1. Today we will talk about our final project, warehouse system. Here are 5 parts to present our final project. First, I will introduce the entity relationship diagram. We have 15 entity order entity around the warehouse, employee, and deployment. As we can see, admin entity is related to employee. The employee ID is admin entity. It's a foreign key of the employee entity. And then is announcement entity, the entity which store all this important information. Employee entity store include all basic information of employees, such as employee ID, job ID, first name and last name, and email, city, state, zip code, and SSN code. And then is goods entity. Goods entity is related to the goods category 2 entity, and the supplier entity. Goods category 2 ID is the foreign key of the goods category 2 entity, and the supplier ID is the foreign key of the supplier entity. And in the goods category 2 entity, goods category 1 ID is the foreign key of the goods category entity. In the inventory entity, the inventory is based on goods information. Goods ID is a foreign key of the goods entity. The stock out entity have warehouse ID is the foreign key of the warehouse entity. Goods ID is a foreign key of the goods entity. The user entity in the user entity, employee ID is the foreign key of the employee entity. The last one is deployment entity. Employment ID is the foreign key of the employee entity. Warehouse ID is the foreign key of the warehouse entity.
Let me introduce our design document, and it's mainly about our entities. And we have 15 entities, and there you can see it shows their primary key, foreign key, and the columns of each entity and relationship with other entity. There is this tables. It's about 15 tables. It's announcement entity, and in the EMP-ID in the announcement entity is the foreign key of the admin entity, and here is the department entity, and the employee entity, goods entity, and goods category 1 entity. Here is a goods category 2 entity, inventory entity, and there is the job entity, a stock-in entity, and a stock-out entity, a supplier entity, a user entity, and a warehouse entity, deployment entity. That's all. Thank you. And the next one will introduce you the circle statements.
Hello. Let me introduce DDL statements. First of all, we need to create a database, and the database name is warehouse statements. And then we could see our database in the navigation panel, just like this. Second, we need to create all the entities in our database. Here are some examples. We create an employee table, warehouse table, and stocking and stockout tables. And after we create all the tables in our statement, we could also see them in the navigation panel. Yes. And third, we need to insert some values into the table. Here we use SQL insert scripts to insert the values. And here also for examples, we could insert the value into the employee table, warehouse table, stocking and stockout table. And we could use a SQL query statement to check the results, just like this. Here's the result of the, for example. And then we also have some implements in our statements. First, we have a table level check constraint to check whether the employee gender information we insert into the table is correct. So first we create a function, then we use this function to add the constraint of this table, of the employee table. And here is and here we use this statement to check, to test the constraint. And you could see the result. Here we got an error because of the check constraint. Second, we have a common data encryption implements in our database to protect the passwords of our employments. First of all, we create a method, and then we create a certificate, we create a symmetric key, and then we open it. Now we could use it. So we insert value into the admin table and we use the table using column data encryption, and then we could see the result. And here's the result. We could see the passwords here is nonsense. Then we could use column data decryption here, and we could now see the passwords. Third, we have to compute table column, and we use triggers and these computed table columns to update the warehouse free area every time we insert a stocking or stock of value into the database. So here we create a function to calculate the area of the stocking goods it takes in the stocking value, and we use this function here. We use this function to calculate the free area of the warehouse after restocking, and the function for the stock out is similar. So let's test this. First, we have 10 empty warehouse. We see the free area of the warehouse. And then we insert some value into the stocking table. Here we insert it, and we could see the free area has changed. Here's another test. We could see the value is also changed. Then we do the same things to the stock out table, and here's the result. Free area has changed and changed. And now let's see the views in our database. We have 5 views. The first view is employee view. We can run this code, and we could see the information of all the employees here. Here we could see the employee's full name, is employee ID, and job's name, and so on. And then we could go to the second and third views. Here is the stocking and stock out views. Here we run the codes, and we could see all the information of the stocking and stock out.
Yeah, this is a question from group 19. So can you please go to ERD diagram?
I'm sorry, we have run out of the battery.
Can you please show us the ER diagram?
Yeah.
So your computer shut down because the battery.
Yeah, because we run
was
out of the
depleted.
battery. Now we
Okay.
are changing the battery. No, now we are changing the computer. I'm sorry. I'm sorry. See the views here. Sorry for the delay. And here's the stocking and stock views. Here we could see the stocking and stock out views contains the stocking ID and the warehouse information, goods information, supplier informations, and it's similar in the stock out views. And now let's go to the fourth views in the warehouse stocking views. In this view, we use multi-value columns, so we could see all the stocking and the stock out, stock in values, stock informations of each warehouse. I'm sorry. And here we could see we have all the stocking IDs here for the warehouse too, and it's similar in the fifth views. Here is the warehouse stock out views. So let's go to the next part.
All right. Here's the report part. Okay, first we import our database into Tableau, a data mining tool. Here we added these two pieces of codes to the original in order to insert new data into the table of stock in and stock out. Then we use data mining tool Tableau to visualize data. As you can see here, we get a bar graph of stock in count. And this is the bar graph of stock out. Here we can see the warehouse free area. Okay, we also use Tableau to get a map, which shows the supplier state. Summary, we have 15 entities, as mentioned above. Second, we have table level check constraint to check the employee's gender. Number 3, column data encryption to protect the password. And computed table column and trigger. We have 5 views, and we also used Tableau to get reports about the sum of the stock in and stock out records, and the report of warehouse failure. Okay, thank you.
Yeah, this is a question from group 19. So can you please show us the ER diagram? Yeah, in this we want to know like in goods table, like why did you use goods category 2 as a foreign key? Why not goods category 1? Like and what's the difference between goods category 1 and 2?
The goods category 1 is more general categories for the goods. For example, in the goods category 1, we have the food category, the maybe like the office staff categories and so on. But in the goods category 2, we have more details like for the food, for the category 1 named food, we have batteries, we have meats, we have dairies, and something else, just like this.
Okay, thank you.
Okay, thank you.
Great, great work and presentation. Thank you, Muhua, Ya, Bo, and Zemyu.
Oh, thank you, Professor.
Great work. Thank you.
Okay.
Team 12 is up next.
This is Team 12. The database we use is Google Play Store Apps database. The purpose of the Google Play Store Apps database is to apply the data to collect and analyze different aspects of apps. After sorting the data, we can see if the apps have high ratings or high downloads and provide users with specific references. Based on the purpose, here are the business problems we addressed. Maintain complete app sales or download information. Keep track of all apps reviews and popularity and find out the most popular categories. And here are some business rules. And based on these business rules, we made our ERD. And this is our ERD. As you can see, in the middle is the app entity. App entity is one of the most important entities in the database. It is the basis for the judgment of other entities. We determine which are good apps or which apps are not popular. For example, each app may have 0 or more installer app relations, and each installer may have 0 or more installer app relations, which means each user may install 0 or many apps, and one app may be installed by 0 or many users. And our next team